Hello everyone, and in this video I want to talk about the curve U attribute and the vex expression where we fit a range into another range, and this is really important for the growth effect. And I will just start with how we can extract the CurveU attribute and what is CurveU attribute and how we can use that for our own growth animation along a curve. So first I will just start with a curve. Let's say I will start with a geo container first, and I will just say curve U. Inside this I will draw a curve, and I will just wait a second. Do I have? Yes. Here I will just click enter, and you can just draw your curve, right? And now I have this curve. So I will just resample this real quick, and I will show you the method where we extract the CurveU attribute from this resample method. When you resample something, you are creating new points first, and if you say, like, if you can increase the level of detail, or you can increase the length or decrease the length, but the important thing here is you get this CurveU attribute. So what this CurveU attribute is about, you see, when I was when I talked about the parametric coordinates, I also talked about CurveU. So I will just create a quick note about this. So, and I will parametric metric. If the spelling is wrong, let me know, but I guess it's right. Parametric. I guess this. We have E here. Parametric coordinates. So it is the local coordinates. If I'm saying that I have a point, first I'll just open PureF, and I will just not know, draw, and I talked about this. You see, we have the 3D world first. Second, we have the local world. This is a square, right? And we have these points. First, this square is in this 3D world. Set y x. This square in this 3D world. But when we talk about parametric coordinate, that means we are talking about the local coordinates, like where this point exists in this local space. That's we call parametric coordinates. And in the curve form, when we talk about parametric coordinates, we are not talking about where this point exists in this world, but we talk about where these points exist in this curve. So if I'm saying here is 0 and here is 1, I can say this point will be at 0.5. So these coordinates are like based on this local space. I'm talking about spatial spatial data here, but this spatial data is based on the local space, not on the 3D space. I talked about this in detail in the parametric coordinate video, and we have let's say this is u, you can consider u, this is v. So this is a 2D coordinate, but when we talk about a curve, we only have 1D because we are only going in one direction. So this parametric coordinate is 0 from 1, and where they exist on this curve, we put a data to it, and this is why we use CurveU, because CurveU is the parametric coordinate of a curve, only one single coordinate, which is u, not v, because this is a 1D dimension, not a 2D thing. Okay, now let's go to Houdini. We have this CurveU attribute, and I will just say I can create a geometry spreadsheet. where I can create a geometry spreadsheet. Okay, what I will do, I will open geometry spreadsheet and I will just split it and I will go here. Okay, now we have something like this. You see, now we have a CurveU attribute which is based on each point of this which goes from 0 to 1. That means this tells us about where these points are based on this curve. This point here means 0, this point here means 1. So if we are at 0 position, if we are at 0, that means we are at the very starting of that curve, right? And if we are at 1, that means it's the end of the curve. So by this method, we can extract this CurveU attribute. But when you resample something, right? When you resample something, it creates new points. So that can create an issue later down the line. I learned this um, from a guy who is like very good at this. So I will talk about it here. And this resample thing will create those new points. But if we don't, if we want this CurveU attribute without doing this resample thing. So in the last video, when I talked about the normalization thing, you see, normalization, we are doing something similar. We are taking the data and converting it into 0 to 1 value to make it easier, right? And in this case, we can do the same. We can do the same. So I will just turn this CurveU off and I will say distance along geometry. And what this distance along geometry will do, it will give you this distance attribute. And now it's saying -1, minus here means it's not applying, it's not working right now, because we need to give it a starting point, and this starting point and to the end point, it will know the distance of each point. First, I will say points and start point is 0. You see, now we have this. So this distance, this this attribute is giving us the distance of each point from this. So this point is at 0, this point is at 0.6, this point is at 1.2, and every other point is doing the same, something like that. So we know this. And when we talked about vector normalization in the last video, we talked about the local their data and what is the total length of this vector. So when we talked about vector, we said that what is this value of x and what its magnitude, total magnitude. So we can convert it into the unit vector with, if we just divide it with its magnitude or its length, right? This coordinate, this component, x component, can be converted, the whole vector converted to the unit vector by just dividing it with their magnitude or length. We talked about this in the last video, and here we will do the same. We know that where these points exist in this, and we can convert this into based on that 0 to 1 data by after normalizing it. So what we can do now, we can just create its measure. So what this measure will do, it will measure the total length of this curve. That's simple. It will measure the total length of this, and when you say, maybe it will create that, but it will create on perimeter, not area. I want length. Yes. So you will see this this curve has a length of 11.68, and this will give you the total length. And we know that where these each point exists, but you see this measure is on the parameter. So it's on primitives, and it is giving us its parameter, which is its length. And what I can do, I can just I need to promote this. I need to promote this attribute to the points level, so we have this parameter on each point, this length on each point, not parameter, sorry, and perimeter. And when you promote this from primitive 2 points, and original name is a parameter, or you can say it's total length, right? So you will see total length. So you will see now we have their relative distance on this curve, and we also know their total length. So what we can do, we can say point, not weld, point wrangle, and when you connect this, and you will see now we can create our own CurveU, which will be based on their attribute distance divided by attribute length. And you will see now we have this CurveU which is similar based on this. So what we are doing, we are converting this their relative distance, right, their distance on this curve and their total length, and we are converting that uh, in between the value from 0 to 1. And how this works, you will understand this by this method. For example, you have this is 0 and this is 1, right? And its length, this point here, they are at something, right? We don't know where they are. We know its total length is 17, right? So this point is at 17 meter, you can say centimeter or meter, and this point is at 0 meter, right? So what will happen if I divide each point, right, each point value with the total value? What will happen? See this, 0 divided by 17 and 17 divided by 17. You will get 0 and you will get 1. So what is happening here? We are converting their position based on this, like in between these two numbers. So because whatever whatever these values are, if you divide it with the maximum value, you will get 1 on this side, and whatever you have here at the 0 position, whatever the value, whatever the total length here you have, you will get another 0. So we are converting this range to this range. That's how normalization works. And in vector, when we talked about x, y, z, because we are talking about 3-component vector here, and when you divide their magnitude, so whatever the highest value will get 1 and the minimum value will get 0, so everything will be here in this value. But their total their total magnitude will be, their total length will be 1 um, after like normalizing it, right, after dividing it with the maximum value. I hope you understand this. And okay, now we know that we have this CurveU attribute. So we know two methods to create this CurveU attribute. First, we can use this CurveU attribute, and then we can use this. But there is another method we can use that will give us the similar thing. And if you just say this curve and you say UV texture, this UV texture, and I will just say I will make this attribute something like something other. I will say UV or new, right? I will say UV new, and this is a vector. You have this arc length spline. Just remember this, we are doing the same thing. My main motto here is to explain the concept here, right? And when you see this, we are doing it on points now. So you see we have this new attribute which is giving us this component which is UV new 0. That means we can say it's x component, y and z. Y and z 0 because this is one dimension line. So we are using the same thing here. And this UV texture is giving us the attribute. We can extract this attribute by point wrangle, and I can say curve U will be equals to a vector attribute UV new dot x, and we are just using the x component of this uv, and you will see now we have this CurveU similar as this, and I will just delete everything, uh, everything except CurveU. So I will say attribute delete, and I will say uv new, I guess. Yes, I don't want uv new, and I will just delete this. So we will have something like this. And the cool thing about this is, which I also learned, is you can give this a null, and you will see or you can just delete this, or you can create a subnet and you can say extract CurveU. So here you don't need to resample the whole this line, and you will get your CurveU attribute from this line. So if I say I have another curve, and wait, what is this? Okay, yes, if I'm saying that I have this curve, right, and I will just connect this here, and you will see now we have this CurveU attribute for this curve also. So this is what I wanted to talk about. So now you know the parametric coordinates and how we can extract this CurveU attribute, but how we can use this CurveU attribute for a growth effect. This is the new thing here, and I will just create another container, and I will say let's say growth along curve, right? You can just turn this off. You can go here. First I will create curve, and here I will create a curve, and I will just make this something like this, and I will go back and I will go curve. I will copy this, and I will come here and I will paste this, and we will extract the curve from this. So now we have the CurveU attribute, and for this CurveU attribute I will just create another point triangle, and I will say attribute growth, and this will be a float attribute. It will be equals to chf, and I will create a channel by the name value, and I will just run this, and we have this value, and I will just animate this value up to here. So this value I will say just keyframe, and when I go here you will have something like this, keyframe commit change. So now this value is changing from this to this. You see our growth value is changing from this to this. Now the important thing here, we know that we have this expression which is fit input and minimum, I can say initial minimum and initial minimum and initial maximum, and we want a final minimum and the final maximum, right? You have this expression which we use to convert one data from one range to another range. So for example, you have, I will just use a bit bright color this time. Okay, for example, you have this range which is 0 to 1, and when you fit something, right, when you fit something you say input. So what we are doing, that we are using this input from this range, and from which range? Initial range, and we are converting it into our final range, right? Final, I will write this final range, right? So let's say if this point exists in this range 0.5. So how this will change? We are fitting what is our input 0.5, right? What is initial range? We have 0 and 1. What its final range? I want to convert this range into, let's say, 0 to 2 now. So where this point will be in this range, if this point is at 0.5 in this range, that's what we are doing. And I can just use this. So what is the new range? It goes from 0 to 2. So I will just use this expression, and you will see that the answer will be at 1, because it's in the middle, so it will be in this at 1 in this range, right? Again, but in the last video I also talked about the age factor here when we convert the age factor from one range to another, because the age is a specific data, right? I talked about in the last video, so you can go check it out. I don't need to go and check that out, so I will not explain it here. Okay, so we have something like this, right? And what I need to do is I have this, right? I will just now explain a very cool trick to um, to like bypass something, to use the fit range but for not converting the range, but it's like a true or false thing. And true means 1, false means 0. So what I will do, I will create something and we will do something like this. We will I need a bright color. So what we'll do, we will do something like this. So it will be a growth effect, right? And what we will do, this will something like this. And when this growth will happen, we know that it's total where this point exists here and here. So we will input the values from this data, like where this point exists in this range, and we will give it a range, and then we will convert that range into 1 to 0 value. And this 1 to 0 value we will put into a ramp. 0 here we will have different color, and 1 we will have different color. And how we are going to do it? So when we say fit, right, what is the input value here? We will input the CurveU value, or we can input the growth value too, because those values are same and we don't need to do anything else. We don't need to normalize it now, because after normalizing we are getting the value. We just need a value between 1 and 0, so we can like see what is happening here. It's a very like fundamental thing here, but the main thing here is this fit, and that how we can extract it, that CurveU data, right? So you will see something like this. We are we are saying that the input is the CurveU value. That means it will, initialize on each point. It will process this expression on each point, and we will get the value, which will be our final, I will say, attribute, and I will say color value, or I will say value equals to, or I will say growth or infection, right? So infection will be fit. We are inputting the CurveU value, right? So we will be converting that range for each CurveU value into this 1 and 0 data. So what is the minimum value? What is the minimum value that we want? For this, we cannot just say 0 to 1, right? We can say that the value is 0 from 0 to 1, but we will use a growth attribute here, and we will convert that. If wait a second, I will just say attribute growth, And for the maximum value, we will say attribute growth, and then we will convert it into this expression. And this expression, you will see that we are saying that the input value is growth, attribute growth, whatever the growth value will have at the frame, and for that point we are talking about, and this growth value will be the same. So the main crucial thing, don't worry about this expression right now, just think about this concept. Like if we are converting this range into this range, and what happens, I say that this range is like now from 0.5 to 0.5. So now we have this range which is just a single point, right? And if I want to convert this range to 1 to 0, or let's say 0 to 1, what will happen? So you see this range goes from 0 to 1 and we are converting a single point, and this range only has one value, right? So if the value we are inputting is 0.3 and we want to see where this 0.3 exists in this 0.3 doesn't exist on this range, it doesn't exist on this range, so it will give you the value 0. This will give you value this 0. And if the 0 point exists, if let's say I say 0.6, if I'm saying I have 0.6, that means where this exists, it doesn't exist in this, but it exists here at this part, so we will get this value 1. So you understand, the values lower than 0.5 will get this, and will get the minimum value, and the values which are like greater than 0.5 will get the maximum value from the new range that we are converting. I will just explain it again, right? Because this is like a really crucial, important thing here, and I will use another another thing. So another color, sorry. So if I have this range which goes from 1 to 0 this time, and I am just saying that the minimum value of this range is 0.5 and the maximum value of this range is also 0.5. So we only have one value which is 0.5. So if the input value is, let's say, 0.4, we are seeing that where this value exists in this range, it doesn't exist here. Where does it exist? It exists on this part. So we will get this value, the minimum value, if right. And if this 0. Let's say I'm sampling like 0.7 now or 6.7 now, so where this 6.7 exists, it exists here. So we will get the 0 value in our final attribute that we want to create. So the main thing here is, I will just say color, and you will see we are ramped from attribute, but there is no attribute. We will create a new attribute, f attribute infection, and I will say fit first. What are the samples value that we take? We will take this CurveU value because they are not changing. At one frame they are not changing, but okay, I should write the expression first, then you will understand. First we will say CurveU, then we will say attribute growth, and then we'll say 1 to 0, and I will just it will work. Okay, you see, you will see that what I did, you see, I sampled the CurveU value first. So what I'm saying that this CurveU, this expression is working on each frame, right? And if I'm saying that I'm at 24, right? I'm at 24. So what is the sample value that we are saying? I'm saying that 0.18411. This is the value. I am changing from this range. I'm changing the value from this range into this range. So this value, growth value, is what? It's 0.02. So we will say where this value, okay, for this second point, we are taking this input 0.03 and the growth value is 0.026, right? Wait a second. Yes. So let's see for the point fifth. The input value, we are saying that it's 0.05. It's 0.5. And the range that it was, which is the range is, we are talking about only one value, right? Because there is only one value, no range here, the growth, and we are talking about 5. It is 0.02. So I will say this is the value that we are talking about, and the range is 0.02 here. And we are converting this range into 1 to 0. Where this 0.5 value exists, in this part or in this part, it's minimum or it's in the maximum side. I will say it's in the maximum side, so the input output value we will get will be 0. And do we seeing that? And yes, the inflection value is the for fifth frame at 24, fifth point at 24 is 0. That's why this point will get a value 0. And when I increase the growth value here, you will see if I'm sampling this value again, right, it's still on the far side, it will get 0. What is happening that this value is getting 1 because this value is now greater than this value. So let's talk about this 0.18 and 0.23, not this. We are sampling 0. What was the data? It is 0.18 and 0.233. Okay, 0.18 and 0.233. So now we are sampling this, right? But here is the growth that we are talking about. So it exists where this is exit. It's greater than it, or it's lower than this value. So we are sampling 0.18. We have a range is 0.2. So where this exists, it exists here 0.18 in this range, and we will say +1, which is 1. And this will give you this inflection value based on this, and you will see when we are moving here, all these points are getting infectious, right? Now we are seeing something like this. And when you give this attribute, infection attribute, and say inferno, so you will get, this is our 0 value, this is our 1 value. So now everything is infectious, and now we are doing something like this, right? So now we are doing something like this. So in this video, my main motive was to understand this concept, this concept, and we can also do something like, we can reverse this. We can reverse this action by, let's say, f infection will be equals to fit attribute growth attribute CurveU, and attribute CurveU will be get 1 to 0, right? And let's see what happens now. You see these colors are reversed, and what is happening here now, we are saying that the growth value, which is this, and we are now seeing that growth where they exist. If the growth exists on the minimum side, it will get value 1, and if it exists on the maximum side, you will get value 0. And you will understand this if you visualize this by this method. By doing this, you will understand that, right? And also if you want to do the same, so you have to change this range from 1 to 0. Like, it's very easy if you understand this. Infection will be fit, you can say attribute growth, and CurveU and attribute CurveU, and if you say 0 to 1, you will get something similar result, because now you are inverting everything. If you visualize this also, you will understand this, right? So this was my point. What if I resample this curve? I will resample this curve and just do this, so you will understand it more. Yes, now we are getting that attribute. We can like visualize it better. And what happens if you say minus something like, if you create a float, let's say blur, or something like variable, and you say 0.1, right? And you say here variable, right? So what is happening here? Now we are seeing this, and if I increase, or if I say chf variable something like this, and I create this, if I increase the value, you will see now we are having this thing in the middle. It's not very sharp now. Now we are seeing this color also. We are not only getting now this value 0 and 1 value. And what is happening here, you see, when I did this, I will just open pure ref, and I will use white color this time. Now the minimum, let's say you are sampling this value 0.5, right? You are sampling 0.5 value, and the range is now wait a second, its minimum value is let's say you are saying like 0.3, and I did 0.1 minus, which is a variable I created, right? So now we have 0.3 and 3, and it will get 0.1, and the value we are sampling is 0.5. So what will happen? You see, we have this. So the data will be like 0.2, 0.3, right? It will 1 or it will get 0, right? But now we have a range 0.2, 0.3. The minimum value is 0.2, and we are sampling 0.5. Where this exists? It exists here, 0.5. So what should we get? We get 0. But in this case, we where is this? We get this middle value. You see 1, and we get here these values. We are not getting purely 1. We are not getting purely 1. So now what is happening? Why we are getting this value? Because you will understand something like this. You will understand this real quick. Because you see, for this the value falls. For this the value falls not in this range, but in this part of this range. So we will get 0 from 1 to 0. If this value falls here, we will get, what we will get? We will get 0. And if the value falls in this part, we will get 1. But what if this value falls in between? Then we will get a between value. Right? You understand? I will just make it super clear here, and you will understand it real quick. Right? Okay, let's do it. I have a range 0 to 1, or let's say 1 to 0, this because we have used 1 and 0. And I have this number now, right? This number we are sampling, right? And the range goes from 0.3 to 0.3, like we did, we just tricked it. So this is just one number. That means there is no range. If this number falls in this area, we will get this part, maximum value. If this number falls in this area, we will get the minimum value, something like 0.2, which whatever number is less than this. But what if a number falls in between? Let's say 0.35, and the range is from 0.3 to 0.4, or just do something. Now the range is from 0.3 to 0.4. So we can have, when we input something which is smaller than this range, you will get this value, which is 1. And if something falls greater than this range, you will get the maximum value, which is 0 in this case. If we are sampling 0.35, which falls in between this range, then we will see something like from this range. From this range, we will not get 1 or 0, we will get something like 0.9. That's how it works. So we are giving that 0.9 and we are getting it from this range value. So we are tricking this, whatever number here, we will get the minimum value. Whatever the number is here, we will get the maximum value. And if we are sampling something which falls in between these, then it will get converted and it will give you the number in between. So in this part, we are getting this number because this number fall like beyond that, or like not in that range. So we are getting 0 and 1 also, right? But we are getting this middle number also. And if I say like 0.1, you will see it is getting shorter, and you will see the growth is something like this now. Right, it's all about 0, 1 and numbers, right? But I hope you understand this, because this is really important thing here. And I talked about how we can extract CurveU, how we can use that CurveU and fit into this range, and we can have the infection thing that we want. And this is it for this video. I hope I cleared some doubts, because I needed to make this video to consolidate the data for myself too. So yes, I understood a lot of things, and I hope you do understand a lot of things, and I will see you in the next one with a new concept.